Okay, we continue moving forward in reference to anything that you see up here, okay? With these compounds, you see the structure, you would name them. Sometimes we will give you the name and then you write out the structure, okay? So again, this is how we would work backwards, okay? Because what does that suffix tell you? It's saturated. And what does it mean to be an alkane other than being saturated? All of the carbon-to-carbon bonds would be what? Are single bonded. Okay. So that tells you the organic family. It's an alkane. All of the carbons are single bonded. What does this tell you? Okay. Why are you right when you say 7? Yeah. Because HEPT just means 7, okay? And this is called the what chain then? As opposed to this, these are all what when it's long and continuous? Yeah, it's the parent chain. So that parent chain has 7 carbons to it. Okay? And we've already established that everything is single bonded because it's saturated. And it also tells you that right here. That gives you the organic family. What is this telling you right here? You're getting a little ahead of yourself. Okay? What does methyl mean? When you get to the end, what you're saying is right, but you're getting a little ahead of yourself. Say that again? Right. So methyl is derived from methane, which means CH3. You can write it like this, or how else can you write it? A carbon with 3 hydrogens attached. Remember, if there's nothing else on here, it's just telling you that these sticks or dashes are hydrogen atoms. And this means methyl, a carbon with 3 hydrogens, or carbon written in a molecular formula like this, CH3. So that tells you methyl, okay? What does di mean? That there's 2 of them, and then this tells you where they're located, okay?
2 from the left in.
Okay? So you can put them here,
And you can put them on the others.
or you can put them here on the second one, okay?
Have one on each.
No, because, and here's why, okay? The question was, can you put one on both of them? What this means then, I'll put this up in purple, CH3, okay? Because if we did this, it would be 2 and 6. That's right. It doesn't say 2 and 6 here. It just means that both of them are on the same carbon. So that is 2, 2 dimethyl heptane. Okay? So this is, we're just working backwards. Again, organic family, saturated, single bonds. It's an alkane. This tells you that there's 7 carbons. Here they are, 1 through 7. This is saying that you've got a methyl group. This says that there's 2 methyl groups, and then this tells you where they're located. Right they are, 2 and 2. Okay. Now, we're going to go ahead and name this one now. Okay. So we didn't put the hydrogen bonds in there. So you tell me left or right side. Do you want to go left or we're not naming it yet. We're just going to put the hydrogens on there. You want to work from left to right or right to left?
Right.
Okay. So how many hydrogens can we put on here?
3.
That's right. Because carbon wants 4 bonds. Now it's got 4. 1, 2, 3, 4. How many hydrogens go on this one?
1.
Just 1. Okay? Because there's 2 bonds to this one. There's 3, and then there's 4. So how many hydrogens can go on this one? Just one. Because there's 2 bonds there, here's 3, and then there's number 4. How many hydrogens can go on this one? Okay. This one? And 3. Okay. So the same, if you want to call it rule, or same way you would name this, is still the same. Find your longest continuous chain. And that doesn't matter whether you start on this side and work that way, or start on this side and work that way. Okay? So what is the prefix for 6? Okay? Now, can we write this suffix? You're saying no, that would be correct. Why can we not do that?
We have to write E-N-E.
You do.
There's a double bond.
Because there's a double bond located somewhere. So it's not hexane, it's rather hexene. Okay? So then the last thing you would need to do is what?
You have to write where your double bond is at.
Okay? And it comes after, not before, it comes after. So what carbon does that come after? Someone said it.
2.
Right. Okay? Okay? 1, 2. After this second carbon, there's a double bond right there. So we could do the same thing for this compound that we did up here. ENE. It's not saturated. Okay? That means there's a double bond somewhere in that carbon. Somewhere in that compound. So this means double bond, alkene. What does that tell you? There's 6 carbons somewhere, or not somewhere. There's 6 carbons in this parent chain of this alkene. And then what is this 2 telling you?
It's telling you where the double.
It's telling you right where that double bond is located. That's right.
So it'd be C6H12.
It would. Yep. Which is, we're going to come back to that later, but no, that's fine. You're just 3 or 4 steps ahead of everybody, and that's fine. But you didn't know we were going to do that. Okay? Now, how is this compound different than these other 2 now? It's got a triple bond. And there's a specific pattern that arises. Single bonds means this suffix. Double bond means what suffix? ENE. And then this is YNE. Okay? So anytime you have this suffix, that tells you that somewhere in that compound there is a triple bond. Okay? Same rules would apply. What is your longest continuous chain here?
4.
Okay, so what is the prefix for 4? Okay, BUT. And then our suffix for a triple bond, as we had established is Y and E. Okay, and then this tells you your organic family, an alkyne, which means there's a triple bond somewhere in that carbon. I said it again. Somewhere in that compound. And then what does BUT mean? That there's 4 of them. Okay? 1, 2, 3, 4, or 1, 2, 3, 4. How do we know if we're going from left to right or right to left? Whichever one gives you a smaller combination or smaller in number. If we go left to right, okay, if we go left to right, this triple bond is after which carbon? The third one. But if we go right to left, it's after the first one. So you can do 1-butene if you wanted to, or if you want to leave it just like this, that's fine too. It's just understood that it would be after the first carbon, which it is. Okay, sorry. Back row, you had a question? Oh, okay. All right. On the left side of this line, is there any questions that just don't quite get this?
Wait, so on the first one, like the way, the reason why you have 2-2 or 2 is because there's 2 of them?
Yes, that's correct. Okay. So, yes.
If you, like on your top one, how you have it on like the other side, if they're both coming down, that'd be something completely different, right? Like that compound's gonna be completely different than the one on the right side of it, right?
This one here?
Yeah.
Yeah, that is completely different.
Okay.
Yep.
So it'd only be written 2, if there's one on the top and on the bottom.
That's correct.
Okay.
Okay. So what would happen then if we put this here and then we take that one off? Everything, you only have to erase one number up here.
You have to erase the second 2.
Okay? So now we would have 2, 4. Okay? And this is why. This methyl group is still there, but on the third and the fourth one is another methyl group, so that's why that 4 goes there. Now, if you were to change that and try to go this way, your combination is 2, 3, 4, and 6. The numbers are too big, so it still has to go in that direction. Okay? Any questions over that? Okay? So I'll put it back to how we had it, which was 2, 2. All right. This one is just a little different than everything we've talked about. Okay? And this is why right here. Okay? So what is this formula inside that box? There's how many carbons? Okay. There's 2 carbons. And how many hydrogens are there? Inside the box only. Inside the box only. 5. Okay? Because remember, this is a carbon-to-carbon bond. Okay? So that means this can't be a hydrogen. That's why that's 5 instead of 6. So you're going to follow what this derived term means. Okay? And we've talked about this before. CH4 is called what? Say it again. Methane. Okay? This is called methane. But if you have CH3, what do we call that? Methyl. Okay? So if we have C2H6, what do we call that? Ethane. Okay? But if we have C2H5, like what we do here, I'll put it in this component here so we can see it the same way. C2H5, it's ethyl. Okay, is derived from ethane. Okay, those are only 2 alkyl derivatives you have to know. Are methyl, 1 carbon, ethyl, if it's 2. Okay, so again, ethyl is derived from ethane. All right. So, same thing. How many carbons are in your parent chain? Okay. So, what is the prefix for 6 carbons? Okay. Now, is everything single bonded? Yes. So if it's single bonded, what type of family is that? Okay. It's ane. Okay. So now, is there anything branching off of that hexane? Yes, there is. 3. Three ethyl hexane. Okay. All right. We're not quite ready to put methyl and ethyl groups on here, okay? Because that does happen. Then you have to alphabetize them. We're just doing the same type of derivatives on there rather than putting, like, for instance, a methyl group up there. We're not quite ready for that yet. All right. Any questions on this? And again, you can work backwards. ANE means what? Everything's single bonded. It's an alkane. What does that tell you? There's 6 carbons. What does this tell you? C2H5. And then what does the 3 tell you? Where's it located? Okay, so 1, 2, 3, 4, 5, 6. There's your 6. Everything is single bonded, so it's an alkane. This says there's an ethyl group, or C2H5, and this tells you which carbon it's on. Number 3. Okay. All right. Any questions on this ethyl group? Okay. Then there's a reason why we got this up here, so we can practice our hydrogen bonds. Okay. Nothing is multiple bonded, so each one of these we can go ahead and put 2 and 3 hydrogens on there. Okay. So your longest continuous chain is called what? Okay. 2, 4, 6, 8. Okay. So it's octane. Okay. Everything's single bonded. There's 8 in the parent chain. Is there anything branching off of that? There's a methyl group on which carbon? On the 3rd one. (3-methyl octane). Okay. So what is the molecular formula for this compound? This is the structural formula. What is the molecular formula? Okay. So C9H20. Okay. So 1, 2, 3, 4, 5, 6, 7, 8, 9. There's our 9 carbons. So now that's 20, not H2O. Maybe I should make that a little smaller. Okay. So this carbon's got 3, 4, 5, 6, 8, 10, 12, 14, and 3 gives you 17, and 3 more gives you 20. Okay. Everyone, would you agree with that? Okay. So what is the molecular formula for this compound? C9H20. I did it again. So used to writing H2O all the time. So what does that mean that these two are from one another?
They have the same molecular formula.
It's got the exact same molecular formula, C9H20, C9H20. But what is different between these two?
One's dimethyl and one's just methyl.
Which means the structure is different. Which you're right. What does that mean when you've got the same molecular formula, but the structure is different? It does. It's one of your vocab terms, starts with the letter I. It's an isomer. Those are isomers of one another. That's right. Oh, I guess we didn't do this. Any questions on that side of the line. Ethyl groups, and this is an isomer of one another. Okay. Finally, how many hydrogens can go on this carbon?
One.
Why are you right?
Because there's triple bond.
Because there's 3 bonds right here. There's our 4th one. This carbon is sharing 3 bonds with this one. So how many hydrogens can we put on here? 0. That's right, because it's got 4 bonds. What about this carbon?
2 and 3.
There we go. All right. Okay. Yep. C4, H6. Okay. And then I never did count all of these. We've got, looks to me like 7, 8, 9, right? 1, 2, 3, 4, 5, 6, 7, 8. Okay. So C8, 18. Okay. All right. I've got this here. We've seen the structures. Now we'll go ahead and see once what the definitions of those actually were. Okay, so we just talked about this. This is where we left off with, okay? Isomers, compounds that have the same identical chemical formulas. In this case, it was C9, H20, but the structures were different. This one was 2,2 dimethyl heptane, and then the other one was, what, 3-methyl octane, I believe. Those are what we mean by isomers of one another. I think we got through this last week, correct? Okay, so this is new material right here. Okay, so when you look at this, unsaturated, that means that all of the bonds in there, they can hold more. There's either a double or triple bond located somewhere in that compound. Okay, we're not going to do a whole lot today because there's just one last thing I want to show you up on the board. Let's see here. Looking forward in the week, okay, you have your vocabulary that was assigned, and that is due on the 14th or Thursday. I would say don't go under the presumption that your track meet will be postponed or canceled. Okay, so that is, again, on Thursday. You're scheduled to go to Menno, in which case you would be leaving at 7:15 in the morning. Oh, it already is. It's already canceled. Okay. So, I doubt if it's canceled, you're probably not going to try to get one to replace it on the same day. You probably can't find one, or the coaches probably can't find one that quick. Okay. All right. I think we'll save this. This is a little tricky, okay? Does everyone have this content that wants it? Okay? So if this is the case, so if you had to draw ethene and ethine, okay? I think it said ethane on there. It should have said ethene, okay? Okay, so if we have this as opposed to that. Okay. So last thing. What is this telling you right here? There's a double bond located. And then what is that telling you?
There's two coming off.
No. There's two carbons. Okay. There's two carbons. And again, that tells you it's an alkene, which means how are they bonded together? Double bond. How many hydrogens are on each one of these? You can do it like that, or you can do it like this, over, under, or one on each side like that. It means the same thing. Typically, I would just put it like this. Okay. So what is this telling you? Okay. And what is that telling you? Okay, that there's two of them. This tells you there's a triple bond. There's two of them. How many hydrogens for this one? And this one. Okay. Typically, this is probably not called ethine ever. It's a type of gas that you find in the shop. We've talked about it before. You mix it with oxygen, and it's an oxygen acetylene torch. Typically, you'd probably call this acetylene rather than ethine, but that is what you're referring to. Okay. Do you feel that you want a little more practice while we've got the time now? Or are you comfortable with everything that we've done so far? So left side over here. Good. Middle and right side. Okay. That's all I have. You can work on your vocabulary, and we will catch up to you next time. We'll start working on some more of these derivatives on there. All right. Catch up to you next time.